of methods, instances and the usage of the keyword new. It also describes access specifiers and the variable scope. Constructor and finalizers and inner classes are also dealt with it in detail. Objectives: classes, methods, more about classes, constructor and finalizer, garbage collection. Classes. The basic element of object-oriented programming is a class. A class defines the shape and behavior of an object and is a template for multiple objects with similar features. Any concept represented in a program is encapsulated in a class. When an application is written, classes of objects are defined. To create a class, a keyword in it followed by a legal identifier and a pair of curly braces for the body is required. Class, class name, body of the class within the begin and end braces. A class called book includes all its features serving as template for the concept. Each property is treated as an attribute of that class. For example, the book's name, the author's name, number of pages it contains are its attributes. The definition of the book class would be class book, open the bracket, string name semicolon, string author name semicolon, int number of pages semicolon, close the bracket. Apart from defining an object structure, a class also defines its functional interface known as methods. For instance, the book can have a method that displays the name of the book. Class book, string name, string author's name, int number of pages, string display name. System.out.println within the quotes name of the book is plus name. Close the bracket, semicolon and close number of end brackets. Once a book class is defined, instances of that class can be created and each instance can have different attributes. When the program runs, instances of the class are created and discarded as and when required. An instance of a class can be used to access the variables and methods that form part of the class. Each instance of the class has its own copy of instance variables defined in the class and hence can hold different attributes. For instance, one object of the book class can contain the attributes of Gone with the Wind, while another may contain that of Learn Java. The methods in the class operate on individual instances of the class. For example, the same display method can operate on both the instances of the book class described above. Suppose we have two instances obj1 and obj2 of the book class. obj1 displays the attribute of obj1, while obj2.display displays that of object2. Note the terms instance and objects are used interchangeably. The Java environment comes with a library of classes that implement a lot of the basic behavior. By creating classes that use the classes provided by Java, highly maintainable programs can be constructed. The following program explains the creation of a class. Open a new file in the editor and type the following code. Class 1. Public static void main. Static void main string args. Int a is equal to 1, b equals 2, int c equals 3. System.out.println within the bracket a is equal to plus a, close the bracket, semicolon. System.out.println b is equal to a plus B semicolon. System.out.println C is equal to plus C semicolon. Save the file as 1.java. Compile the file using java 1.java. Okay. Then run the file using java 1. The output appears as shown below. A is equal to 1, B is equal to 2 and C is equal to 3. The class is declared in line number 1. This is line number 1. Class. What is the class name? It is 1. Okay. The main method, the entry point to all Java application programs, is defined in line 2. See, this is the main method. This is line number 2, main method. Okay. So, here in lines 3 to 5, 3 variables that are local to the main are declared. Okay. These variables are displayed using print ln in lines 6 and 8. Okay. So, this is from 3. 1, 2, 3. Int A is equal to 1, int B is equal to 2, int C is equal to 3. Okay. So, line numbers 3 to 5. There are 3 variables that are local to the main are declared. So, here these variables are displayed using print ln in lines 6 to 8. So, 1, 2, 3, 4, 5. This is 6, 7, 8. So, here system.out.println, it starts from line number 6 to 8. Now, I have typed this same program in the notepad and I have saved as 1.java. So, what it should display? 1, 2, 3. So, this is the program. Okay. So, now I will run this program. Type it in the notepad. Save it. Now, I will compile using java 1.java. Okay. Now, run java 1. Okay, students, you can observe here whatever we had assigned, the same thing it is displayed. A is equal to 1, B is equal to 2, C is equal to 3. Okay. Attributes. Attributes are individual properties that differentiate one object from another and determine appearance, state and other qualities. Each attribute has a corresponding instance variable. Instance variable. Data is encapsulated in a class by declaring variables inside the class. Declaration.variables declared in the scope are known as instant variables. Instant variables are declared in the same way as local variables, except that they are declared outside the scope of any particular method, such as main. For example, a class named point can be created with 2 instance variables, namely A and B. Every object of this class has its own copy of the instance variable. Class point. Begin int A comma B semicolon close. Dot operator. The dot notation is used to obtain the value of the instance variables. It has 2 parts, namely the object on the left side of the dot and the variable on the right side of the dot. Dot expressions are evaluated from left to right. The general form for accessing instance variables using the dot operator is given below. The syntax of the dot operator is object reference dot variable name, where object reference is the name of the object and the variable name is the instance variable. We can store values into instance variables using the dot operator as shown below. P dot x is equal to 10 semicolon, P dot y is equal to 20 semicolon. We can refer to values of instance variables using the dot operator as given below. System.out.println within the brackets x is equal to plus P dot x plus y is equal to plus P dot y, close the bracket, semicolon. The new operator. The new operator creates a single instance of a named class and returns a reference to the object. For example, an instance of the class point can be created as shown. Point P is equal to new point P semicolon. Here, P is a reference to an instance of point. There is a critical distinction between how simple types and objects are manipulated in Java. The variable P is a reference to the object. It does not actually contain it. Note, when an object is no longer referred to by any variable, Java automatically reclaims memory used by that object. This is known as garbage collection. When a new object is created, a distinct set of instant variables are obtained. Each object has its own copy of the instance variables of its class. So, changes to the instance variables of one object have no effect on the instance variables of another. Each object's instance variables are separate and distinct from the others. The following example depicts the usage of the new operator to create an instance of the class. It also demonstrates the creation and usage of instance variables and the use of the dot operator in variables. Open a new file in the editor and type the following code. Class insvar int a is equal to 10, int b is equal to 20, semicolon, public static void main string args, insvar 1 is equal to new insvar system.out.println the value of a is plus insvar 1.a system.out.println the value of b is insvar 1.b. Okay, so now I have typed this whole program in Notepad. Okay, this is the program. Just observe this. I will increase the font size. This is a program. You have to type it in the Notepad. Okay, so after compiling this program, it will display the value a equals 10 and b equals 20. Now I have saved this program and now I will compile it in DOS prompt. Javac is var dot java. Okay. Next is Java file name, class name, ins var. Okay, it should display a equals 10, b equals 20. Okay, so please observe this. The value of a is equal to 10, the value of b is equal to 20. Two instance variables a and b are defined in the class insvar. The main method creates an instance of the class using the new operator. When the object is created, the instance variables a and b are initialized to 10 and 20 respectively. Lines 6 and 7 display these variables, accessing them using the dot operator. Multiple references of the same object can be created. In the illustration, a single object of a class named chord is created with two variables referencing it. Chord P1 is equal to new chord semicolon. Chord P2 is equal to P1 semicolon. Any changes to the object referenced by P2 will affect the same object to which P referring. The assignment of P1 to P2 does not allocate memory. Subsequent assignment to P1 will simply unhook P1 from the original object without affecting the object itself. Following example depicts the referencing of objects. Open a new file in the editor, that is Notepad, and type the code. This is the code. Okay. So here class called int x comma y, public static void main string args, chord p1 p2, p1 equals new chord, p1 dot x equals 50, p1 dot y equals 50, p2 equals p1. p1 dot x is 100, p1 dot y is equal to 75. Then system dot out dot println. Coordinates of p1 are p1 dot x plus p1 dot y.
System.out.println coordinates of P2 are P2.x plus P2.y. Okay, so this is the program. I have typed it in a new file in a notepad editor. Now I have given the class name is called as the file name. Now we will run this. We will compile and run. When you compile and run, you will get the output as follows. Okay, javac. File name is your class name. This is your file name. Okay, called. You should remember it is case sensitive. Okay, javac coord.java. Okay, since there is no error, you will come to the next problem. Now give java coord. Now this is the output. Coordinates of P1 are 100,75. Coordinates of P2 are 100,75. Okay.
Chord class has two public instance variables, x and y. In the main method, an instance of the main method, an instance of chord is created, and the reference is stored in the variable P1. The assignment statement in line 8 copies the reference P1, not the object it is referencing to P2. The values of x and y of the object that P1 is pointing to are modified. Lines 11 and 12 display the variables x and y of the objects that P1 and P2 are pointing to. The output of program shows that though only P1 was modified, changes are reflected both in P1 and P2 since they were pointing to the same object. Class variables. Class variables are global to a class and to all the instances of the class. They are useful for communicating between different objects of the same class or for keeping track of global states. The keyword static is used to declare a class variable. For class variables, there is only one copy of the variable. Every instance of the class has access to that variable. We have to use the dot notation to access the class variable and instead of using the object's name on the left hand side of the dot operator. The class name can be used. Thus class variables can be accessed without creating an object of that class.